All right, guys, here we are into Unit 4, Lesson 1, Relationships and Triangles. Now, this particular video might be a little bit longer, but you do have a little extra time to go through it. So make sure that you take your time and don't stress too much because we are giving you the extra time. Okay, so to start with, we're looking at perpendicular and angle bisectors. All right, so this is what our focus is for this lesson. There's three main chunks that we're going to look at, which is for you to be able to identify a perpendicular bisector and an angle bisector, use theorems about bisectors to find measures and figures, and then finally write equations of perpendicular bisectors. For this unit here, we're going to look at how do I use properties of angles and perpendicular bisectors to identify equal distances. Your main vocab word that you need to make sure you understand is equidistant or equidistant. Depends on who you're talking to in the way that they say that word. So, do you remember what it means to bisect something? It means to divide into two equal parts. Okay, so if you bisect it, it's going to be divided into two equal parts. So, what does that mean for us today? Well, if you recall this document here, or this picture here, you can see a diagram where we have a perpendicular bisector. If you remember from the past, a perpendicular bisector is going to be perpendicular to a segment and it divides it into two congruent segments. It also passes through the midpoint. So you know all of this information from knowing that you have a perpendicular bisector. Now, something is equidistant if it's the same distance. So if it's the same distance from a point, it's equidistant. In this case, we could easily say that point A and point C, from point A to point C and from point C to point B, if you were to create segments there, they would be equidistant. They would be the same length, the segments would be. But in this case, we'd say from A to C, it's the same distance as B to C. So from A to C, see here's from A to C, it's the same distance as if you started from B to C. All right, they're equidistant. So how does that help us? Well, that brings us to our first theorem here, which is the perpendicular bisector theorem. Basically, this theorem is telling you that if you have a perpendicular bisector of a segment, then the distance from the endpoints, right, the distance from the endpoints of the segment that's bisected is equal to a point on the perpendicular bisector. So if you're at the endpoints, it's going to be the same distance from the endpoints to a point on the perpendicular bisector. Now, this point can be anywhere on the perpendicular bisector, and they'll be the same distance away from the endpoints of the segment that's being bisected. So from A to C, it's the same distance as B to C. I could pick another point that's a little lower, and it would still be from A to that new point. It's the same distance as B to that new point. Now you have the converse of the perpendicular bisector theorem. The converse basically says that if you know that the distance from a point on a bisector is the same to the endpoints. So if you know you have, for example, this point D, from D to B and from D to A, if it's the same distance away, then you know the point D would actually be on the perpendicular bisector of the segment AB. So D would be along the perpendicular bisector. All right. Okay, let's try to put this into practice to have an understanding. So here it says to find the measure of RS. So if we look at the diagram, we notice that from S to Q, it's perpendicular to RP. Well, we already know that those two segments then, or the line and the segment, are perpendicular. And then you'll notice from P to Q and from Q to R, they're equal to each other. So those segments are congruent, which makes us think about the fact that we have a perpendicular bisector. If we have a perpendicular bisector, we know that the distance from S to P is the same distance as S to R. So with that in mind, that means that we know the length of SR, or RS, it's equal to the length of P to S. So 6.8 for both. Okay, if we find the measure of A to D. Well, in this case, now we have to do a little algebra. Look at the diagram again. We see a 90-degree angle. So we know that the line and the segment are perpendicular. We see that from C to B and from A to B, they are congruent. So we know that's going to be a perpendicular bisector, which means the distance from point D to A is equal to the distance from D to C. So 3x plus 14 should equal 5x. They're the same distance apart. So we can use the perpendicular bisector theorem and make the application. We set those equal. We use our algebra skills, and we've now solved for x. Are we finished? No, we're not finished because it says we are looking for the length from A to D. So we actually need to plug in the value we found for x, and we get 35. So AD is going to equal 35 units. All right, now we're moving into the next portion, which is writing the equation of a perpendicular bisector of a segment. Now, what do you remember about the slopes of perpendicular lines? Hopefully, you remember that two slopes that are perpendicular will multiply to -1. Or maybe you remember that they are the opposite sign reciprocals. In other words, if I have a slope of 3 over 4, the opposite sign would be negative. Reciprocal would be 4 over 3. So, using what we've already learned in the past, we're going to make application to that now with our perpendicular bisector. Here is an example where it asks you to write an equation of the perpendicular bisector of the segment with the following endpoints, where P is at -2, 3, and Q is at 4, 1. So, what could we do if we were given this particular problem? Well, it's always nice to have a visual when we're dealing with geometry. So, the first thing you may want to do is to graph the line segment PQ on the coordinate plane. And then, if you think about what we're looking at, it says you have a perpendicular bisector. So you're trying to write the equation for the perpendicular bisector. Remember, the perpendicular bisector will pass through the segment PQ at the midpoint. So we need to find the midpoint from P to Q. To find the midpoint, we can use the midpoint formula, where you add the two x's together and divide by 2, add the two y values together and divide by 2. So the midpoint in this situation is found at 1, 2. So that's where the midpoint of segment PQ is. Now that you know where the midpoint is, this will help you to write the equation of the line that is perpendicular to the segment PQ. Here's where you start to think about slope and how that works. So, in this situation, if we're going to find the slope of the perpendicular bisector, we can use the points that we have to do that. The slope of PQ turns out to be negative 1/3. The slope of the perpendicular bisector needs to be the opposite sign. So instead of negative, it needs to be positive, and it has to have the reciprocal. So that means instead of negative 1/3, which is the slope of PQ, the blue line, the slope of the red line is actually 3. Positive, and it's the reciprocal. Now you can write the equation. The perpendicular bisector is going to have a slope of 3, and it passes through the midpoint, which was at 1, 2. We can start by writing slope-intercept form, y equals mx plus b. We can now substitute the values in. We know that the midpoint is at 1, 2, so we replace the x with a 1, the y with a 2, and the slope is b, which is 3. Sorry, I said b. My mistake. The slope is m, which is 3. We're trying to find the value of b. We solve and we get b is negative 1. To finally finish, you need to write the equation of the red line, which means you just replace the slope and now your new y-intercept, which is the b. So the equation of the perpendicular bisector is y equals 3x minus 1. The last thing we're looking at now is the angle bisector. Here's the angle bisector theorem, similar to the perpendicular bisector theorem. In this case, if we have an angle, for example, angle BAC, and then you have an angle bisector, which is AD, right? It's going to be the same distance from the side of the angle, which is, in this case, AB, as it would be to the other side of the angle from A to C. So any point on the angle bisector, if we draw a line straight to the sides of the angle, it has to be perpendicular if it's the distance there that we're looking at. It'll be perpendicular to the side. So just like this one, that's how you get the distance. You might recall this, we talked about it in a previous unit, where to get to the distance from two different points, you need to have the distance from a point to a line. We talked about it being perpendicular. So in this case, from D to the side, it has to be perpendicular if we're looking at the distance. Now, if we take the point D and we find the distance from D to each side of this angle, because it's on the angle bisector, it's going to be equidistant, or the same distance. The converse of this basically says if we have two segments that are perpendicular to the sides of an angle, so like from D to B and D to C, if they're perpendicular to those sides, and you see the distance here, if those distances are equal in length, then that means this ray that comes down the middle is going to be an angle bisector. So again, this is the converse, right? So right now, in the converse, we don't know if AD is a angle bisector. We're trying to figure that out. So if we use the information around us, we can figure that out. If you know that it's an angle bisector, it helps you to know something about the two smaller angles. If you're ever trying to prove triangles congruent, or you're trying to calculate an angle measure. So here's something to keep in mind and to think about. This is like a real world situation. Here it says that a soccer goalie stands in the interior of angle LBR. So that's the outer angle, LBR. Notice that it's using the goalposts as L and R, okay? And this is formed by BL as a ray over here and a ray BR there. With this, the question comes up. Why might the goalie want to stand on the bisector of angle LBR? Could you think of any reason why this goalie would want to position himself on the angle bisector of LBR? So a good reason for the goalie to stand along the angle bisector is because he's basically the same distance to each side of that angle that's formed, and it would allow him to have an easier way of blocking shots or that might go to either end of the goalpost. So he's pretty much cutting down the amount of distance and making it equal in both directions, whether he has to block to the left or block to the right. So it gives him a better chance of being able to stop the shot from going in. All right, look at this here. This problem says to find the measure of GFJ. So from GFJ, so from G to F to J, we're looking for the angle right here. Okay, that's the measure we're trying to find. Well, let's look at the information we have. From the information that we have, we see that from J to G, it's 7 units, and from J to H is 7 units. Notice the perpendiculars, which means that that's the distance to those sides. They're the same. The perpendicular means that this FJ is a what? It's an angle bisector. So if this is 42 degrees, what can you then expect on the other side? That it's also 42 degrees. All right, how about this one here? Find the measure of RS. Again, you'll have to use a little bit of algebra with this one. But if we just analyze the situation, well, right now it looks like we have two angles that are being cut by a ray, and those two angles are equal to each other. So this is clearly an angle bisector, which now means the distance from this point S to P and S to R are equidistant. See the right angle? So we know that from the point to the sides, they're the same distance, which means that this segment and this segment are the same length. So we can set them equal to each other. By setting them equal to each other, do a little algebra, and we get the value of x, which is 5. Again, here we're not finished because we're trying to find the length of r to s, which means we just need to substitute in the 5 for x. We do that, we find out that rs turns out to be 25. All right, as usual, you have your two options. You can go ahead and start in the practice, but again, if it's not something you want to start on, you don't have to. And the other option is to just wait till you come to class. So if you're going to do the practice, you only have to do one of the levels. You don't have to do all three. And if so, it starts on page 296 of the text. If you don't have the text and you're using a PDF version, then it'll start on page 9 of the PDF. We are using chapter 6 of this text, and this is the level 1 practice, your level 2 practice, and finally, your level 3 practice. All right, see you all in class.